And friends, let us look at the memory management, because we presuppose memory while solving for the data structures and algorithms. So first of all, the list node head is created, which is pointing to null, and which has a memory address of 100, and create a tail which has the same address of 100, and then we check, come into the while loop, we check if both the lists are non-null, it's true, and we check in the if condition, if L1.val is less than L2.val, 1 is less than 3, definitely. So we are going to make tail.next to point to the first list. And since it's the same memory location but different pointer context, the head will also now point to 1 and 2. And let's say 1 has memory address of 200 and 2 has 201. And now we are saying tail equal to tail.next. So this becomes the tail, and then we go back, and then L1 is equal to L1.next. So now L1 is 2. So we check both the lists are non-null, we check L1, 2 is less than 3. We say tail.next is L1. So L1 is 2, we have already said it. That's fine. And now L1 is equal to L1.next, L1 is now null. And then tail is equal to tail.next. So tail is now pointing to 2. And then we come to the beginning of the while loop, we see that L1 is null, it's false, the condition fails, we come out, we say tail.next, we said if L1 is null, we set it as L2, if L1 is not null, we set it as L1. So definitely L1 is null, so we are going to set the tail.next as the list 2, which has a memory address of 300, 301, and head will also point to the same memory location. And we're done with the tail. We're not going to do anything because we're only interested in the head, and we're going to return head is pointing to null. We're going to return head.next, which is 1, 2, 3, 4. Head pointing to 1, we're going to return, and that's the entire sorted list. So this is the memory management for the linked list node. And one more important thing that I wanted to talk was, as we are moving from classical computing to quantum computing, time and space, these two, the continuum, becomes a very important constraint, because classical computing consists of 0 and 1, quantum computing consists of the superposition of states of the quantum bits or qubits. So it can be any of these states. So we may have to relook into how we perceive time and space, not from a Newtonian model of absolute time and absolute space, but more from a relativist model, or the theory of relativity by Minkowski, or the capstone that was done by Albert Einstein. Also, we have to unify Prof.Immanuel Kant's time and space as a priori presupposition when we are solving something inside time and space. So we'll talk about time and space, trying to unify different concepts from Prof.Immanuel Kant to Albert Einstein, from the Newtonian, what is happening and what it means, how we could perceive going forward. It is just a theory and a hypothesis. So we'll explore that in the next video. Thank you so much for watching.